Hello guys, welcome to our video of the series called C# for beginners. So we've actually been converting between types this series without necessarily thinking of it as its own topic. Remember, int.parse or casting to double for accurate division. Today we are pulling all of that together properly, covering exactly how and when C# lets you move a value from one type into another and what can genuinely go wrong if you are not careful. Let me show one code. Int maybe a whole number equals 10, int other number equal 3. Console.writeLine maybe whole number divided by other number. Okay, remember this exact gotcha from the way back in operators lesson, integer division, silently dropping the decimal. This entire lesson is really about understanding conversions like this properly, so surprises like this stop being surprise for you. Let's build up from the safest, most automatic conversions all the way to the ones that need real care. Let's start with the easiest, safe kind. Conversions C# does completely automatically without you asking. Let me show you one code. Int whole number equals 10, double decimal number equals whole number. Okay, so double decimal number equals whole number. Notice we are assigning an integer directly into double variable with zero special syntax at all. C# just allows this automatically. Let's see the output here. Decimal number, and as you can see, it's just 10. And printing it, we genuinely get 10 now safely stored as a double. Why does C# allow this without complaint? Because it's genuinely safe conversion. Every possible int values fits perfectly inside a double with zero risk of losing any information. This is called an implicit conversion. And there's a quick remember of the type hierarchy. This respects, let me show you. In A is 5 long, B equals A, and then float C equals A, and then double D equals A. Okay, generally going from a smaller numeric type to a bigger one is always implicit and safe into long, into float, into double. C# lets this happen automatically because nothing can go wrong. Implicit conversions happen automatically with no special syntax, specifically because they are always safe. No data can ever be lost going this direction. Now, what about going the other direction, a double into an int? Let's try it the same way. Double price equals 0.99 and int whole dollars equals price. Price. See that? Compile error. This genuinely won't compile at all. And that's actually intentional. Going from double to int risks losing real information, that 0.99 part especially. C# refused to do this silently, forcing you to be explicit about it. The fix for that would be int. Okay, and int whole dollars equals parentheses int closing parentheses price. That int inside the parentheses right before the value is called a cast. We are explicitly telling C#, yes, I understand I might lose information here, do it anyway. And if we here just print the data, console.writeLine whole dollars, as you can see, it's just 19. Notice it does not round, it just chops off the decimal entirely, so $90.99 becomes 90, not 20. And here's a worst demonstrating situation. Let me show you. Int big number here, maybe 300, and then here's a byte type small byte equals byte big number, and console.writeLine small byte, small byte. And here's a genuinely important warning: byte can only hold values from 0 to 255. Casting 300 into a byte does not throw an error, it just wraps around silently and gives you 44, which is genuinely completely wrong for what you probably intended. Casting bypasses the compiler safety net. It trusts you it completely, so you need to actually know what you are doing. So let me show you the output. That's actually 44. See that? And explicit conversions or casting is required whenever data might be lost, and while it definitely works, it puts the responsibility entirely on you. Make sure the results actually make sense, okay? No, casting works great for numbers, but what about converting something like a string into a number? Casting genuinely does not work for that format, right? Maybe string number text. Maybe we have 42, right? And int number equals just int number text. Does not work, right? This won't compile. Casting only works between compatible related types, and string and int are not directly related that way. So how we can do that is string number text equals 42, and then int number equals convert dot to int 32 number text. Okay, console.writeLine number. Okay, so convert dot to integer 32 number text. The convert class gives us a whole family of methods specifically for converting between genuinely different types: strings to numbers, numbers to strings, and more. Okay, and let me show you other convert formats with it. But before that, let me show you the output. As you can see, we converted it to integer type and it's 42. So other converting situations with convert class, the convert dot to double, maybe 90.99, 90, and bool b equals maybe convert dot to boolean, and here true. Okay, and string as convert dot to string 42. Okay, console dot writeLine d and b and s. Okay, to double, to boolean, to string. The patterns consistent across all of them, just different target types. Okay, and here one of the genuinely useful behavior we can have is, for example, we have double price, maybe 3, price 3. Okay, and it's 90.99, and int rounded equals convert dot to integer 32 price 3, right? And console dot writeLine rounded. Let's see the output, but before that, let's see that output. As you can see, we converted all of types using to double, to boolean, and to string. So here we are actually getting the double, boolean, and string values. So, and then let me show you the other example that we wrote here. As you can see, it's just rounding. Important difference from casting: convert dot to int 32 or to 64 or whatever actually rounds to the nearest whole number 20 here, rather than just chopping off the decimal like our earliest cast that we did with just inside the parentheses, which gives us 19. Yes, was remembering which behavior you actually want depending on the requirements of the task that you are doing. That convert class handles conversions between genuinely unrelated types like the string and numbers, and was remembering rounds numeric conversions instead of truncating them, unlike the direct cast. Now we've actually used this next one constantly throughout this whole series, already remembered int.parse from way back reading console input. Okay, so let me show you example with that. Age, maybe text equals 25, int age equals int dot parse age text, console dot writeline age, and it's 25. Int.parse age text, genuinely familiar by now, this specifically converts the string into the type you call it, on this case integer, right? And there can be other examples like string price text, like 90.99 equals, and then maybe double price equals double dot price double dot parse price text, console dot writeline price. Okay, the same pattern works on the other numeric types too. Double dot parse for converting a string specifically into a double. So let's see the outputs here. We are converting the age to integer from string using the int.parse, and then here we are converting the string to double using the double.parse. Okay, there is also one kind of situations that we should be careful, so let me show you that example. Int, maybe broken, int.parse parse, maybe not a number. Okay, remember this crash risk from the exception handling lesson. Parse genuinely throws an exception if the text is not a valid number of that type. Parse methods are specifically for converting strings into a specific target, maybe genuinely similar to convert, but more direct and tied to that one specific type we are calling it on. Okay, and then naturally remember the safer alternative we covered back then. Let me show you, if you don't remember. String user input equals not a number. Okay, bool success equals int dot try parse user input dot out int result if okay, if success console dot writeline parsed result, else console dot writeline that was not a valid number. Okay, in .TryParse user input out int result, same idea we've now seen a few times. Datetime.TryParse back in the date lesson, right? following this exact same pattern, returns true or false, and hands the actual value back through that out parameter without ever crashing. TryParse is generally the safer choice whenever you are converting text that might not actually be valid, which honestly is the most of the time when it's coming from the user. And as you know, users can type whatever they want when using our applications. So using the TryParse is much more safer way than just directly using the integer.parse or other value.parse. Okay, now let's cover something genuinely subtle that most beginners never even realize is happening. Let's push a number past its types limit. Int max value, maybe max value, int dot max value, and console.writeLine max value int overflowed equal max value plus 1 console.writeLine overflowed. Okay, let's see the output. See that that's the max number of the integer and it's the minimum number of integer. In dot max value, the absolute largest number, and int can't hold. And adding just one more to it, look at that, it wraps all the way around to a huge negative number. This is called overflow, and by default C# lets this happen completely silently, no error, no warning, just quietly wrong math. Okay, this is genuinely dangerous in real applications. Imagine this happening inside a banking calculation. C# gives us a way to catch this explicitly instead of letting it silently corrupt our data. Let me show an example, maybe with try and check it. Try check it int max value to value int dot max value int overflow equals max value plus 1 console dot writeLine overflow, and then here catch overflow exception x console dot writeLine overflow code x dot message. Okay. Check it, curly braces wrapping around our risky math, right? This tells C# actually watch for overflow inside this block, and if it happens, genuinely throw an exception instead of silently wrapping around. Combine it with try catch. Remember from a few lessons ago, we can now catch this properly instead of it corrupting our data unnoticed and silently. Checked turns silent dangerous overflow into genuine catchable exception worth using in any calculation where correctness truly matters, like a financial code. So let me show you what it happens when we run it. As you can see, overflow code and our arithmetic operation resulted in an overflow. Why? Because we are using checked here, and whenever the problem is detected, it just kind of throw an exception, and in catch block we are catching the exception and we are showing to user. So that's very useful whenever we are calculating some kind of application that's very important and also prone to errors. Okay, and naturally there's an explicit opposite to unchecked for when you genuinely want that wrap around behavior on purpose. Let me show you. Unchecked int max value equals int dot max value int wrapped equals max value plus 1 console dot writeLine wrapped. Okay, unchecked curly braces. This explicitly allows the silent wraparound behavior guaranteed regardless of any project-wide settings that might otherwise make overflow checked by default. So let's see the output. And as you can see, we are getting the negative number. That's the minimum number of the integers that can hold. Now, genuinely, why would you even want a silent wraparound? It actually shows up in some specific legitimate scenarios. Certain hashing algorithms, for instance, deliberately rely on this wraparound behavior as part of how they work. For everyday application code, though, this is genuinely rare, and check it is what you'll reach for far more often when overflow actually matters. Unchecked is really about explicitly documenting intent. I genuinely want this wraparound behavior on purpose. Don't worry me about it, okay? Alright, let's tie today's conversions together with a realistic example, maybe processing a batch of user submitted prices, okay? So let's see the example. Maybe we have the array of strings and row prices equals, maybe we have 99.99, and then we're gonna have maybe 450, and then not a price. Okay, and now double total equals 0, int valid count equals 0, and then for each string price in row prices total. Oops, before that we need to check if double dot try parse row price out double price double price double, and then here total plus equal price double, oops, price double, and then valid count plus plus, else console dot writeLine skipping invalid price, and we can show what is invalid price, row price, not we have a price, okay, and then we can say console dot writeLine maybe total in dollars total, and console dot writeLine valid entries valid count, and rounded total equals convert to integer 32 total console dot writeLine rounded total would be in dollars and rounded total. Okay, here you can see a batch of raw price strings, genuinely including one invalid entry, and we it's actually should be raw prices. Why it's not? Oh, it should be price. Okay, and we loop through the TryParse each one safely, skipping anything invalid rather than crashing, sum up the valid prices, and finally convert to integer 32 to get a nicely rounded total at the end. Okay, so TryParse for safety and convert for a clean rounded summary. This is genuinely close to real code you'd write, maybe processing any kind of external potentially messy numeric input in real life or kind of real application while you're working. So that's all for today's lesson, and your challenge would be writing a method that takes an array of strings representing ages safely, parses back each one using TryParse, skips invalid entries, and prints the average age using the LINQ average method from a few lessons back. Bonus, wrap a deliberative overflow scenario in a checked block and catch the resulting exception. Okay, so to summarize today's video, today we covered implicit conversion, which happens automatically because it's always safe, explicit conversion or casting for when you are deliberately risking data loss, and the convert class for converting between genuinely unrelated types, parse and TryParse for converting strings into numbers safely, and finish it with checked and unchecked arithmetic for controlling whether silent overflow crash or wraps around. Type conversion is something that touches nearly every program you write, especially anything dealing with user input, so these tools are genuinely worth having solid, comfortable familiarity with. Okay, next time we are covering file input and output, reading and writing files in C#. See you there. Take care.